The next important topic is cellular manufacturing or one-piece flow production. Cellular manufacturing. So what is it? I told you, working cells. It should be divided into working cells. This is also related to that. So cellular manufacturing means, dividing, subsection of GIT and lean system is a cellular manufacturing. It encompasses a group technology. Okay, what happens in cellular manufacturing is, it is a U-shaped system firstly, then it to move as quickly as possible. It helps you move as quickly as possible. It helps you produce wide variety of similar products and making as little waste as possible. Then how do you implement this? So before that, cellular manufacturing, at the end where you have summary, it's very nicely given there. Let's just go back to that and let's just study once. So in cellular manufacturing, what happens is, it is an assembly line, multiple cells are used. It is an assembly line where multiple cells are used. Each cell comprises of one or more machines which accomplish the certain task. Each cell comprises of one or more machines which accomplishes certain task. The product moves from one cell to another, the next cell, each station completing part of manufacturing process. Each station, it is completing part of certain task. So what is it? It is an assembly line, multiple cells are used, each cell comprises of one or more machines, and each and every step accomplishes certain task. Then the product moves from one cell to another by completing part of the manufacturing process. It is a U-shaped design. U-shaped design is given to this so that this allows the supervisor to move less and have the ability to readily watch over the entire process. Then goals of cellular manufacturing. What are the goals? There are 3 goals. One is move quickly, make wide variety of similar products, very less expensive, very less wastes. Then advantages of cellular manufacturing: flexibility in operations, changes are easy to make. Flexibility in operation, changes are easy to make. Variety of product scaling. Minor changes can be easily and quickly implemented. Conducted by logic, so reduces flow time, flow distance, then floor space, inventory handling costs, scheduling transactions, and scrap and rework are reduced. Okay, what are the limitations of this? Limitations of cellular manufacturing. What are the advantages? Remember 4 points. What is it? Flexibility in operations, changes are easy to make. Small changes can be implemented as and when required. Then variety of similar products. Then flow distance, floor space, inventory, all these things are reduced. Then limitations. What are the limitations? Decrease in production flexibility. See, it increases what? Flexibility of operations, but it decreases what? Decreases production flexibility. Flexibility of operation is increased, but it decreases the production flexibility. Operation flexibility increased, advantage. Production flexibility decreased, disadvantage. Then difficulty in realignment of cells. Once you fix, it is fixed. It is difficult to realign it. Then decrease, when there is a decrease in demand, it is very hard to realign the cells. Then changes in flow may be very costly. To change the flow, it is very costly. That is what cellular manufacturing is about. The next topic is Six Sigma. So in Six Sigma, it is a quality improvement technique. As you know, it is a quality improvement technique whose objective is to eliminate the defects completely. It is a quality improvement technique whose objective is to eliminate the defects in all the aspects which affects the customer satisfaction. The premise of Six Sigma is that by measuring defects in a process, a company can develop ways to eliminate them and practically achieve zero defects. That is 34 errors for 1 million products produced. Then this is what Six Sigma is all about. This is the summary part of it. But when you come back to this, is there anything else that we have to study in Six Sigma? DME IC and DME DV. Implementation of Six Sigma. How do we do that? For existing product, it is DME IC. And for the new product, it is DME DV. DME IC, what happens? Problems and customer requirements. First, okay, define what? Problems and customer requirements. Then measure what current performance. This is existing, right? So you measure what current performance, then measure the process to determine the current performance. Next, third one, analyze what root cause. Analyze root cause of the variation and poor performance. What is the root cause for the variation and poor performance? Then fourth one, to improve the process by addressing and eliminating the root cause. You analyze the root cause. Now in the fourth step, to improve, what will you improve? You improve the process so that root cause has been eliminated. Then fifth one is control, means maintaining the improved process and future process performance. Control means maintaining the improved process. You already improved, you maintain that, and future process performance, you also maintain the future process performance. This is what is DMA-IC stands for. So define the problems, existing problems, then the customer requirements. Based on that, DMM, measure what is the current performance. What is the current performance? Then third one is A, analyze what root cause of this particular variation and poor performance. Then fourth one is once you analyze, now it is time to improve the process by addressing the root cause, by addressing and eliminating the root cause. Then fifth one is, so you've improved the process, you have to control that. Control means to maintain that. You have to maintain the improved process and future process performances. That is about DMA-IC. DMA-DV, how do we do that? So DMA-DV mein first thing is project goals. Define what is a project goal, because it is not yet started, right? Over there you define what is the current issue. Here, goal. So define the project goals and customer deliverables. Define the project goals and what are the customer deliverables. There it was customer requirement. Here it is customer deliverable. We are yet to deliver, correct? So project goals and customer deliverables. Define that. Then measure what? Measure customer needs. Remember this, customer needs, because it comes in all the points. So customer needs is something that we work upon. So measure what are the customer needs, specifications. Here their needs and specifications. Based on that, you analyze the process options to meet the customer needs. So you analyze the process option to meet the customer needs. Analyze. Then fourth point is design. Design what? Design the process to meet the customer needs. Analyze the process options to meet the customer needs. Then fourth one is design. Design the process to meet the customer needs. Last one is verify. What verify? Verify the design performance. Verify the design performance and ability to meet the customer needs. Verify the design performance. Have you designed it? Verify that. So verify the design performance and ability to meet the customer needs. Ability to meet the customer needs. So these are the 5 things. First one is define the goal and customer deliverables. Second one is customer needs. Measure. First you measure the customer needs. DMA, analyze the process to meet the customer needs. Then fourth one, DMA-D is design the process to meet the customer needs. Fifth one is verify. You have already designed, now you verify whether it is meeting the customer needs or not. That's all. So the last thing is limitations of Six Sigma. Let's remember 4 points of limitations of Six Sigma. What is that? Not all products need Six Sigma, right? Like you don't want that perfections. So the second one is it focuses only on the quality. Then Six Sigma does not work well with intangible results. If you cannot see the results, intangible, then it doesn't work well. Then Six Sigma focuses on specific type of process only. It focuses on specific type of process only. Okay, Lean and Six Sigma combine to get the maximum results. Then we have something called process innovation and business process re-engineering. First is process innovation. What happens in the process innovation? 3 things. Innovation should happen in 3 things. 1, production. 2, delivery. 3, support services. Production, delivery, support services. Innovation should happen in these 3 things. Remember that. In production, how can you buy, equipment, like standardizing the equipment, technology, improving the technology and everything. That is production. Delivery, supply chain, delivery systems. Then in support services, purchasing, maintenance and accounting should be kept properly. That is what is support system. Remember 3 things. In process innovation should happen in 3 things. 1 is production, delivery, support services. Next, business process re-engineering. Last topic. What is business? It should not take more than 3 minutes. Let's start. Business process re-engineering means what? It's a radical redesign, fundamental rethinking and radical redesign. These are 2 components also. If you remember the definition, you will also remember 2 components. There are 4 components in business process reengineering. One is what? Fundamental rethinking, radical redesign, dramatic improvements, dramatic improvements, and end-to-end business processes. Okay, these are 4 BPR components. Then main stage of BPR, the process, how do you implement it? So first is identification, process identification. Then 3 R's will come, triple R. What is that? First you identify. Second one is process reassembly, redesign and rationalization. Reassembly, redesign, rationalization. Rationalization means to remove those things which are not adding value to the process. Okay, that is what is BPR is about. Principles are removed, so we need not study that. That's it, guys.